Assalamualaikum and hi, we are from Group72. Today we will be talking about an engineering ethical issue regarding Tacoma bridge collapse case. In this case, we will discuss in detail about the problems, parties involved, facts and data, and also the impact from the case. Tacoma Bridge was a suspension bridge that spanned the Tacoma narrow straits of Puget Sound between Tacoma and the Group72. On November 7, 1940, the cable band at the midspan of the north cable slipped and slid along the bridge. This allowed the cable to separate into two unequal segments, which contribute to the change from vertical to torsional movement caused by the wind. Then the structure's twisting movement became self-generating and it then totally collapsed. This situation can be related to the Code of Ethics of National Society of Professional Engineers, Section 2.1, where engineers should hold paramount the safety, health and welfare of the public. In this situation, they violated the Code of Ethics, which are serving and protecting the public. There shall be a one-tunnel model testing for this project.
The Tacoma Bridge was discovered to buckle and sway dangerously in windy situations not long after it was built. On the day of the collapse, it experienced wind of about 19 meters per second. The center stay was torsionally vibrating at frequency of 36 cycles per minute. The torsional vibration amplitude increased during the next hour, and the motion had switched from continuously rising and falling to a two-wave twisting. The center part of the bridge remained motionless, while its other two halves twisted in opposite directions at 14 vibrations per minute. The deck of the bridge was insufficiently rigid and was easily moved by the winds due to the use of thin and narrow roadway support girders. This drastic torsional motion was started by a failure of a cable band connecting to the center of the diagonal ties. Due to alternative sagging and hogging of span members, the towers holding them were pulled towards them. Further, visible and predominant cracks developed before the entire bridge crashed down into the river. However, engineers still debate the exact cause of its collapse, including aerodynamic instability, random turbulence, and periodic vortex shedding.
The Washington State Legislature created the Washington State Toll Bridge Authority and appropriated $5,000 to study the request by Tacoma and Bruce County for a bridge over the Narrows in 1937. The bridge was designed by Leon Moisseiff, a well-known New York bridge engineer. Prof. F.B. Farquharson of the University of Washington was responsible for conducting experiments of oscillation. The collapse of the bridge was recorded on Kodachrome 60mm film by Barney Elliott and Harbin Monroe, owners of the camera shop in Tacoma. The film was sold to Paramount Studios, who then duplicated the footage for new release in black and white and distributed the film worldwide for movie theaters. Castle Film also received distribution rights for 8mm home video. In 1998, the Tacoma Narrow Bridge was selected for preservation in United States National Film Registry by the Library of Congress as being culturally, historically, and aesthetically significant. Theodore Van Karman was trying to learn what caused the collapse, and he was the director of the Guggenheim Aeronautical Laboratory and a well-known aerodynamicist.
Suspension bridges were both more elegant and economical than railway bridges. Thus, the suspension design became favored for automobile traffic. Unfortunately, engineers did not fully understand the forces acting upon bridges. Neither did they understand the response of the suspension bridge design to these poorly understood forces. Furthermore, the Tacoma Narrows Bridge was built with shallow plate girders instead of the deep stiffening trusses of railway bridges. Note that the wind can pass through trusses. Plate girders, on the other hand, present an obstacle to the wind. As a result of this design, the Tacoma Narrows Bridge experienced rolling undulation, which were driven by the wind. It thus acquired the nickname Galloping Gertie. Strong winds caused the bridge to collapse on November 7, 1940. Initially, 35 mph winds excited the bridge transverse vibration mode with an amplitude of 1.5 feet. This motion lasted 3 hours. The wind then increased up to 42 miles per hour. A support cable at midspan snapped, resulting in an unbalanced loading condition. The bridge response thus changed to a 0.2 Hz torsional vibration mode with an amplitude up to 28 feet.
Thankfully, no human life was lost in the incident. The only fatality was a cocker spaniel named Tabby, who died after he was abandoned in a car on the bridge by his owner, Leonard Cotsworth. He tried to return to the car with Tabby, but he could not, as the bridge motion had become too violent. Professor Frederick Farquharson, who had been involved in the design of the bridge, tried to rescue Tabby. He managed to reach the car and open the door to coax Tabby, but he was bitten by the terrified dog when he attempted to remove him. Next, in terms of financial, the country lost $1,600,000 in toll revenue during the bridge outage. The complete loss of the bridge is $6 million, and to remove the bridge, the country has to spend about $350,000. In order to construct the new replacement of the bridge, they need to spend another $11,200,000, and in total, $9,150,000 of money needs to be spent to resolve the problem.